I'm Anil Kumar, and in this video I'm going to discuss different types of counting principles which we have been using to find the number of outcomes. So we have a very simple example here to get the basics. There are three statements here which will lead to three examples. The first one is select all two-letter combinations of letters from the set of four letter A, B, C and D. So that's an exercise for you. You are given a set which has four letters A, B, C and D. You need to select two-letter combinations, write them out, right? The second one is find all distinct four-letter arrangements from the set of four-letter A, B, C, D. Same set of A, B, C, D. You need to find how many arrangements can you make using all four letters. The last one here is how many possible subsets can we have from the set of four letters A, B, C and D. So in this example we have just taken four letters A, B, C and D, and we will see how we can look at it in different ways. Let's begin with the very first statement here. It clearly indicates select all two-letter combinations. So it is the word combinations which is critical. Now when we work on counting principles, combinations for us means that order is not important, right? So in a group we have two elements, one can come before the other, but if only those two elements are there, then two groups are same. So two-letter combinations from 4, so that is 4C2. Two-letter combinations from 4 is 4C2, right? Which means 4 factorial divided by 2 factorial times 4 minus 2 factorial. So that gives you 4 times 3, then 2 factorial will cancel. Normally we do like this, right? 2 factorial, and this is also 2 factorial. That is 2 times 1, perfect. So the idea is that you could always cancel this. So you get 4 times 3 over 2, and the number of sets which you get here will be 6. And you could write them out. So beginning with A, for example, you can say, let me use another color. Beginning with A, you could say AB, AC, AD. Beginning with B, if I write BA, it is already there. So BC and BD. Beginning with C, CA is already there, CB is already there. So those combinations are already there, right? So only one left is CD. Beginning with D, we already have covered, right? So we are left with these 6 combinations. So these are the two-letter combinations which you can form using A, B, C and D. So I hope this term is very clear to you, right? Now let's look into the other one. It says find all distinct four-letter arrangements from the set of four letters A, B, C, D. Now when we say four-letter arrangements, that means we have 4 positions, 1, 2, 3, 4, which has to be filled by A, B, C and D, right? Distinct means order is important, right? So distinct means order is important. So we have 4 letters here. The choices which we have to fill in the first position is 4. Either one of these 4 can get. So 4. Once we choose one, we cannot repeat it. We are left with 3, and we have option to use one of these 3, and then from 2, and then from 1. So in this case, the result which we get is 4 times 3 times 2 times 1, and total number of options will be 4 times 3 is 12, 12 times 2 as 24, right? So you can make combinations with these 4 letters and you'll get to 24 such combinations, correct? So that is how you can use the counting principles, and the answer is 4 factorial, right? Now getting to the next one here is, how many possible subsets can we have from the set of 4 letter A, B, C and D? Now subsets mean a set may have 1 element, a set can have 2 elements, can have 3 elements, can have 4 elements, right? Likewise. Such type of questions you could consider kind of like this. We have 4 positions again, right? Okay. We are again working with these 4 positions. 1, 2, 3, 4. And let's say a set A. We may have A or we may not have A. Do you see that? So you can say we have A or we do not have. So we have 2 choices. Whether in this set we can include A or we may not include A. Similarly for B, we may include B or we may not include B. For C, we may include C or we may not include C. Same is for D, we may include or we may not include, right? So total number of combinations will be, here we have 2 positions, right? 2, 2 and 2. So it gives us 2 to the power of 4, 2 to the power of 4, which is 16, right? So there are 2 options. So it is basically 2 times 2, I should say times 2 times 2, right? So we get the result 2 to the power of 4, which is 16, right? So there are total 16 possible subsets. Remember, in this, it includes a null set. Null set, which we say sometimes phi or empty set. Is it okay? Represented by nothing in it, right? So that is nothing, 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 nothing. We do not select A, we do not select B, we do not select C, and we do not select D. In that case, those are the total number of combinations, right? So to begin with, let's understand these terms which we will be using frequently. And I hope this video helps you to understand these terms. I'm Anil Kumar. You can always share and subscribe to my videos. Feel free to post questions. And if you like, that'll be great. Thank you and all the best.